Let's talk about simplifying rational expressions. So we have two examples here, and for both of these examples, we're being asked to simplify and find the excluded values, or what x should not be equal to. Okay, now the number one skill that is needed to accomplish both tasks is factoring. We have to be able to factor all of these numerators and denominators, which are just forms of quadratic expressions, or binomial, polynomial, trinomial, and monomial expressions. So let's just go ahead and jump in and take a look at number one. So as I said before, the main thing we want to do to be able to do is factor once again. So in doing so, we're going to factor each expression. We have x squared minus 4x. We have x squared, what's that, x squared minus 16. Then we have x squared. And then last, we're going to do the x squared plus x minus 12 and what that equals. And really for that one, we're going to make sure we put our ones here. That's going to come back to be important. Now, going back to the first numerator, when we factor this one, they both have an x in common, so that's just going to give us x times x minus 4, and that's it. The greatest common factor is x. You take that out, you can take an x from both of those, and the leftovers is x minus 4. And if you wanted to check it, you would just distribute. So x times x is x squared, and x times negative 4 is negative 4x. The next one is a perfect square binomial. So what that means is we can just take the square root of 16, because 16 is a perfect square, and we're going to take the positive and negative form of that square root. So the square root of 16 is positive 4 and negative 4. So we would write it like that: positive 4, x plus 4, and negative 4, x minus 4. And that's how you factor that one. For x squared can just simply be written as x times x. Now for the last one, this trinomial. This is one method, or one way I'm about to show, that pretty much works if a right here, that's a, is equal to 1, or whether it's greater than 1. This method will work both ways. So what we want to do is combine, not combine, but multiply a times c. And in this case, a times c, which is positive 1 times negative 12, that equals negative 12, and then we need to factor it. So we have negative 1, positive 12, positive 1, negative 12, positive 2, negative 6, negative 2, positive 6, negative 3, positive 4, and positive 3, negative 4. And those would be the factors of negative 12, but then we need to add them or combine the factors to see which one is going to give us a positive 1. So when we do that, when we combine them, that's going to give us positive 11. This is going to give us negative 11. This is going to give us positive, not positive, but negative 4. This one is going to give us positive 4. This is going to give us positive 1. And this is going to give us negative 1. Now, the factor pair that we're going to use is the pair that gives us positive 1, which is the negative 3 and the positive 4. So when we write our factors for this this trinomial here, we're going to simply just put x minus 3 times x plus 4. And now that we've factored everything, let's go back and look at our expression. Now that we've factored everything, we can rewrite our expression as in form of its factors. So the first numerator was x times x minus 4. And then the denominator is going to be x minus 3 times x plus 4. And really we can stretch this whole thing out and continue the numerator on the other side. We had x plus 4, x minus 4. Stretch that out. And then the other denominator was just times x times x. Now at this point we can just go ahead and simplify and cross out things that are common on the top and the bottom. For example, we have an x here and an x there, so we can get rid of those. We have a x plus 4 and an x plus 4 there. We can get rid of both of those. And now we're just left with the leftovers, which we can go ahead and write right here. So one way we could keep our answers in factored form. So this would be x minus 4 times x minus 4, and then on the bottom we could have x times x minus 3. Or we could simplify this some more. We could just say x minus 4 squared, and that's going to be divided by x squared minus 3x, and that would be the simplified form. You could also write it this way as well. Now when we're looking for the excluded values for the x not equal to values, okay, we're only taking a look at the denominator. So if I come back over here and I write with my this was a denominator, let's use a different color. This was a denominator, and the x squared was a denominator. So both of those, we want to take a look at both of those, what happens when we set them equal to 0. So x squared plus x minus 12 equals 0, and then we just want to set x squared equal to 0. These are both of the denominators. Now for x squared equals 0, if we just take the square root of both sides, alright, x is just going to equal 0. That's one of our answer choices there. One of the values that x cannot equal. Okay. Now the other value that x cannot equal, in order to solve for x here, we're just going to factor it, and we already have factored it. So it was x minus 3 times x plus 4, and we don't want that to equal 0, because if the denominator equals 0, then the function is going to be undefined. So when we do that here, we set each one of these equal to 0, and we solve for x, and then for x minus 3 is going to be x equals 3, and for x plus 4 is going to be x equals negative 4. So for this rational expression, these three values here would be the values that you do not want x to be equal to. Okay, and remember, this right here is our simplified form.